everybody. I'm going to do another quick little video update on the engine build. It's kind of like part 5.5. That's probably what I'm going to call it. Not a big change in direction, just some continuation of the internals that's going into the motor. Got some more parts that have arrived and settled on camshafts and lifters, and made some changes to the kit that came from Summit on the lower end. And we'll just show you really quick what I've gotten from the Summit and some parts from Amazon. Just looking for a little bit of value where I can find it, keep the cost down a little bit, and then probably do a quick little video on getting these pistons ready to go in the motor, as far as numbering them and orienting them so that when the time comes, I'm ready to just slap them in the block and just try to get as much done as I can, waiting for the block to get back. Just speed up the assembly time once it's ready. I don't have to go do this stuff after the fact. So we'll just show you some of the parts we got here. All right, so here's the bench full of goodies. Start with these here. These are going to be the new main cap bolts for the crank. I'm going to get rid of the factory ones and go with the ARP head bolts. The reason I went with the head bolts and not the head studs is after consult with the machine shop, they said that I would have to go ahead and have the crank journal align hone to go from studs to, or I should say go from bolts to studs. And after they'd already determined that the alignment was good, I didn't necessarily see a big reason to go ahead and do that. Pay them twice to measure and do that. So I'm just going to go with new main bolts. That way the align honing won't need to be redone, and the ARP fasteners are going to be a little stronger than the factory ones to begin with. I did get a Cloy's timing chain set. This is a double roller set. Of course, I don't even know, to be honest with you, why they even sell single rollers anymore. I don't know why anybody would put a single roller into a new engine, but it's a steel gear set with the appropriate double roller chain included. Kind of a decent value. I think this is just a little bit under $30 for the timing chain set. I should have been keeping track of this, but somehow in the back of my mind, I'm probably not keeping track of the cost so tightly, because some things you're just better off not knowing at the end. Trying to put this whole thing together, I think a rough estimate is about $3,000. because that's about what I could have just bought a new one for as a crate motor. Of course, there's no fun in that. It's not why I'm doing it. Of course, I could have just bought a crate motor, but this is because I want to build this motor myself. So if it goes over budget, if I spend a little more than I would have of just buying one off the shelf, so be it. Now, I mentioned in the previous video, or I guess 2 videos ago, about the kit that came with from Summit with the lower end parts, that it had King bearings in it, and I did do the research that I said I was going to do on King bearings, and they're legit. I've actually read they have really good material, and King bearings are quite acceptable. But the ones that came with the Summit kit were aluminum silicate bearings, so they're kind of the lower end on bearings, and I said then you don't skimp on those. So I did go ahead and upgrade to some tri-metal bearings from Seal Power. I got a match set rod bearings. These have been new surface coated. This is kind of like the latest material, latest manufacturing processes for bearings. So this is definitely a step up from the ones that came with the kit, not by brand, but just by materials. I want to make it clear that I'm in no way saying that King does not make good bearings. But the Seal Power ones were cheap enough, and see how that surface is totally different. You can definitely tell that isn't just polished aluminum. That's definitely a heavier duty material for the mains there. And it has the same type of coating on the, there's one of the front and rears. Different type of coating on it than the aluminum silicate does by any manufacturer. So upgraded bearings. That's a good deal right there. These were, I think, $25 and $27 respectively. It was $25 for the rods and $27 for the mains. So for $50 to not go after the fact, after you've spun a rod or something, or a bearing or something, and wish you hadn't have done it when you built the motor, it just made sense to do the upgrade there. Now the big deal is, last video I talked about, I was using the numbers off of
the Lunati bare bones cam, and that's what I ended up buying. So it came as a kit. I've got lifters, hydraulic flat tappet lifters from Lunati. These are pretty nice. I mean, don't know one lifter from the other except for roller versus flat tappet, but I actually did read something. Somebody once said on the internet video that I was watching that if you get a lifter that has these lines in the middle of it, it means it was made by Delphi. And apparently Delphi, of the 2 or 3 lifter manufacturers that are actually in the world, whether you buy them from Comp or Lunati or Crane or whoever makes this stuff, there's really only 2 or 3 companies in the world that make lifters. Actually, heard that on one of the videos from Uncle Tony's Garage. He was talking about lifters and problems he's had with getting them off the shelf and having them fail brand new. And he talked about how there were only 2 or 3 different manufacturers, but apparently these are the better of them because they're made by Delphi. Then the cam. Unbox this guy real quick. Right here, this is a hydraulic flat tap camage. Not going to take it all the way out because you've seen a cam before, but there you go. It does have the lift profile that I had listed on that video, and I am probably going to go ahead and run the 1.6 ratio rockers with it to get just a little bit more lift out of it. So keeping that in the plan. The cam card for this guy, I don't think I lost it. You know, they're supposed to have cam cards on these things, and I didn't actually see a card. I'm just now realizing it. I've only had this box open once before, and I certainly didn't take anything out of it then, but I'll be damned if I don't see a cam card right off the bat. How silly. Well, I'm sure the specs are on the internet, and I'll be able to pull it off of there. Now, one thing I did do before I went ahead and settled on this one here, I was talking in that video about trying to figure out your dynamic compression ratio and how you have to use the IVC to determine that. I did do the math and on an IVC, and I believe on this cam, it's not 41 degrees, it's actually 33 degrees of IVC. So the dynamic compression ratio is going to be a little bit higher than what I listed, which is actually a good thing. So just by its nature, only having like a 31 degree valve opening and piston coming up in the bore, it's going to give it just a little bit more power because the valve will close sooner and you'll get more available stroke to make power with. So that was a benefit out of this. Other parts, I got a cheap Spectre timing chain cover. This one has nice 12-point bolts in it. Comes with that. Actually comes with this narrowhead 12-point socket to get in here, so that makes it easier instead of having to get your fat little 12-point on there and try to tighten these up with it hitting the side of the cover. This has the crank seal already installed on it, which was nice. Obviously it comes with gaskets, water pump gaskets too. So this guy here was cheap too. It was like $24, and including the bearing or the seal, and so that was a pretty good deal. And along with that, I got this same manufacturer Spectre timing marker that I can throw on. Just mount it up like that on the motor when it's ready to go in. I guess that goes, well, I'll figure it out afterwards. But that attaches to a couple locations on the timing cover. What else did I get? So I got this nifty little anodized piston ring compressor. 4030, I have 4030 pistons, so I've already slid a piston through here and it does go through, so it has the right bore. That matched up okay. I do have one of those hand cranked finger slicer 3000 models, but I was like, this thing's, I think was, I don't even remember, maybe 15-20 bucks. So I went ahead and got that. Got a crank socket, spin the motor while I'm doing all the assembly, putting the rods and everything together. So got that going on here. So I don't have to stress the crank bolt continuously while I'm trying to turn the motor over. That's going to be a lot less stress on that threaded area in the nose of the crankshaft. Trying to think of what else we got laying around here. I thought there were a couple other things, but maybe not. Oh, yeah, I got a set of, I'll show them. Mr. Gasket engine cleaning brushes. So I've got all size for the bores in a Chevy motor, from the main journals, the little oil passages, the piston bore obviously, and the lifter bores. I can scrub those out when I do the final cleaning before assembly. Let's see what I got. I think that's about it as far as new parts, but that's about 85–90% of a short block here in my hands right now. I think the only thing I'll need to get still is a oil pan and an oil pump. I'll need to get those coming, a balancer and flywheel. Still need to get those. So that's what's going in the motor. You guys have seen it right here. Go ahead and maybe pause here and see if I'm going to set up and do the little showing of marking the pistons so we can keep the caps and rods together so they don't get mixed up during assembly, which if you do them one at a time, there's really no way to mix them up, but you do have to keep track of which one's going on which side of the motor so that the chamfer on the lower, on the crank side of the connecting rod faces the counterweights of the crankshaft. If you get that mixed up, you're done, you're screwed. So I'm going to go ahead and mark them in number, like pistons 1 through 8, and I'm also going to mark the rod and the connecting cap as match sets for 1, 1, 2, 2, 3, 3, so that if I'm paying attention like I'm supposed to be, there's no way to screw that up. So I'll get that going. Well, before I get into the numbering of the pistons, I did find the cam information. It's not a card like I've always seen, which is just like a little index card. It's actually on the warranty registration form that was folded up like this with all the materials. So yeah, it just wasn't what I was looking for, but I do have the information. So here's the cam card right here. It has all the information on it that I need to do any calculations I need to do. Also has all the instructions for setting preload, proper break-in, and a bunch of information that is important. And I will be reading through this more than once before I install the cam, because I'm trying to do as much pre-education as opposed to post-disassembly of a failure before I get all this going. So apologies, Lunati, you did include the information. It just was not exactly what I was looking for in the way it was printed. Okay, I've got all the pistons lined out here, and I was getting ready to go ahead and start numbering them, making sure I had some indication on the cap and the rod that those belong to each other, when I noticed that there's actually a stamping from the factory. Don't know if you can see it there, but there's a numbers here. They're not 1, 2, 3, 4, 5, 6, 7, 8 or anything that would be linear for the engine assembler, but I think there's just serial numbers of the actual piston that was cast, but they match cap to rod. So what I'm going to do, instead of going through all the trouble of etching all these rods and caps, is on my engine build sheet here, when I'm doing the checking for the clearances, I am going to go ahead and log down that serial number that's already on the connecting rod and cap so that I know which one went in which cylinder, and if it ever has to come apart, which piston was in which bore. So we'll know in that way that this was all done, and if it ever comes up, if it ever has to be disassembled, reassembled, we'll know which one to put back in which cylinder. The pistons do have dots on them for front to back. So when I laid these out, what I was doing is they're in order right now: 1, 2, 3, 4, 5, 6, and this is actually 8. Piston 7 is at the machine shop. You have to do them so that this chamfer on the surface of the rod is facing the counterweight of the crankshaft, and this flat machine surface here matches up to the flat machine surface on the opposing piston, so that they're like this when they go into the engine. If you put them together the wrong way, if you have the chamfer facing the flat, you're going to screw up the motor. You don't want to do that. So you have part of the reason I was going through this step is I don't want to make that mistake when I was putting the engine together. And if you number these now, if you line them out and you know that there is a outside, inside, outside, inside, outside, inside orientation to those chamfers, there's no way, unless you're just really not paying attention, you'll put them in the cylinders wrong and screw up the motor when you're building it. So just save some time right there. That's cool. So yeah, that's it for this video, and we'll see when the next one comes out. Hopefully it's going to have something to do with that damn block, because I am just eagerly awaiting its arrival.